Data obtained from Lidar scanning can be used to create point cloud objects. A point cloud is a collection of 3D data that can represent ground, vegetation, building models, or other natural and man-made objects. Point cloud data is commonly stored in a variety of formats. In this example, we will create a civil 3D point cloud using a collection of aerial LiDAR in the form of Esri ASC files. Note the wide variety of point cloud formats we have to choose from. And I can select multiple ASC files to build one civil 3D point cloud. The wizard tells me how many points are resulting and how many source files. The point cloud is processed in the background, so we can continue to work while it builds. Once the point cloud is created, I can leverage the different style options to visualize my cloud in many different ways. And develop a better understanding of the region and its topography. I can switch to the elevation range style, which is colored based on the ground elevation. Red being the lowest, which makes sense in the areas of the river. By changing the point cloud density, I can see more or less detail in the point cloud. The display of point clouds is important, but to maximize the value of a point cloud, data can be extracted and used for eventual production. Airborne LiDAR, such as the Cloud in R model, is useful for building a conceptual terrain model for preliminary design. Once we have survey information, we can easily replace the conceptual surface for more detailed work. Civil 3D will build a surface from the currently visible elements of the point cloud, so I'll adjust my density to be about 50%. I'll use a window to pick just the area that I'm concerned about. This is a great way to manage large data sets and to build the surface only from the information I need in a certain area. I'll bring in an image for some additional context. The image is georeferenced, so Map Image Insert command knows exactly where to place it. To make it easier to see, I'll go back to that Map task pane and turn off some of the elements that we no longer need. And put my point cloud in No Display. I can drape this image on my conceptual surface to get a feel for the terrain. This will also be useful for some simple design validation or visualization that you could do any step along the way. There are several different ways to see the surface. We'll just quickly look at it in Object Viewer, in Realistic View. And note how the image is draped over the contours, over the terrain. We're not simply limited to viewing the surface's contours. A slope analysis combined with quick profiles will really give us an understanding of what's happening with the terrain. I simply change my surface style to slope banding, run a quick analysis. that will use colors to show me different designations of slope, with red being the steepest. I can develop a better understanding of my site even now in the conceptual stage. I can split my viewport into two so I can see both the plan view of my surface and a quick profile. Before even sending surveyors out to the field to pick up more detailed data, or before gathering aerial topography or other forms of more detailed terrain surveying, I can begin to develop a relationship with my site, understanding trends, making considerations about where might I put stormwater facilities, or where might my areas of steep slope be, and accommodating that buffered area that we saw in the preliminary planning stage. Annotations are important for production work, but I can use surface labels such as spot elevations and slopes to also understand what's happening at any stage of the game. And as work progresses, those labels will automatically update with my refined surfaces. Another tool I can use is the water drop tool, which has a look at the terrain model and helps me determine where water will flow during a rain event.